Resolving forces on inclined planes. Example 3. So a particle with weight 2g newtons is acted upon by a 4 Newton force parallel to the incline, pushing the particle up the incline. The incline is smooth, which means there are no frictional forces present. The only information given about the angle is that the tan ratio of the angle is 3/4. We want to work out the value of acceleration and the direction of acceleration for this particle. We know that there will be acceleration somewhere, either up the slope or down the slope, but we don't know at the moment which direction it will be in. The mass of the particle is not given, but we know the weight is m times g. So to calculate mass, we make the weight equal to mg, and then by just crossing out the g's, we know the mass is 2 kilograms. Now when looking at forces on this system, we need to focus on forces which are parallel to the slope, because our acceleration is along the slope. If tan theta is equal to 3/4, then representing this information in a right angle triangle and working out the missing side, which is 5, allows us to work out the ratio for sine theta, opposite over the hypotenuse 3/5, and cos theta. So anywhere we see, for example, sine theta in our calculations, we can replace with 3/5. And likewise cos theta can be replaced with 4/5. So I'm going to take this direction along the slope, so this is parallel to the slope, and it's the upwards direction along the slope as positive. So when I look at forces, it will be 4 and then minus 2g sine theta, because that's pointing down the slope in a downwards direction, equals mass times acceleration. So we have 4 minus 2g sine theta equals the mass times the acceleration. Sine theta we know already is 3/5, and then we solve to get the acceleration as minus 3.88 meters per second squared. It's negative, which means the direction of the acceleration is in the opposite direction to this. So it will be down the slope instead of up the slope. For practice, try these questions.